All right, welcome back, guys. In this video here, we're gonna start chapter 3. The first lesson is called Measures of Center. So, chapter 1, we discuss how to collect the data, how to classify data. Chapter 2, we talk about how to organize the data, how to graph the data. And then chapter 3, we're gonna analyze the data using statistical computation, some of the standard ones. So 3 is a little more competition than 1 and 2, but there's still a lot of stat concept to be discussed. So 3.1, the title is Measures of a Center. So in this lesson here, we're going to analyze a given quantitative data set, and we want to discuss how to compute some of the measurements. And measure center, there are 4 measure center. This referring to the center of the data set. So given a data set something this big here, how do we quickly describe, all these numbers without going through every single one of them? And that's where the measure center comes in. We look at this and we say, okay, what is one value we can say the magnitudes of the earthquake can be just described using single value, right? So that's where the measure center come in. We can just look at this and say, okay, I can describe that using the mean, or the median, or the mode, or the mid-range. So those are the 4 measurement of center we have. We have, mean, median, so I have mean, we have median, mode, and mid-range. Okay, so those are the 4. So let's talk about what are the 4 what are these 4 measure center. By the way, measure center, we define that as so measure center is a value, is a numerical value at the center of the middle of a data set. Okay, so that's the definition of measure center. Let's talk about the mean first. Mean is typically referring to average. This is the arithmetic average that we are familiar with. So there's 2 forms for this. We have the sample mean, meaning referring to the sample average or sample means of a smaller set from the populations. X bar, the way we compute the arithmetic average is we add up all the numbers and we divide by how many number are there, meaning we take the sum of all the data value and then we divide by the sample size. So this here, this notation, this is the sum notation, which is adding, right? So let's say if our data set has n values, we can say, all right, x1 plus x2 x of n. So that's the sum, and then divide by how many there are, which is n value. So that will give us a sample mean. The other mean is the population mean. We have various same way of computing it, but the notation is different. Population means we're gonna denote that as, instead of x bar, we denote that as mu. So Greek lowercase m is called mu. This is the mean for populations, and we're going to take the sigma of all the x and divide by the population size. It's not going to be lowercase n, but it's going to be uppercase n. So 2 different type of mean. We have the sample means, and then we have the population mean, right? Okay. The second measure of center is median. All right, just like the word median, right in the middle, right? So this is the median. This is the data value. The data value when the middle value. Sorry, let me just go ahead and erase this here. So this is the middle value when the data values arrange in order. meaning we take the data set and we arrange that data set and we look at the middle value. For example, if we have 1, 1, 3, 4, 5, then the median would be the 3 here. All right, so that's the median. Okay. Next we have the mode. So the mode is the value or the data value that occurs the most. Okay, so same example, if we say the data set we're looking at is 1, 1, 3, 4, 5, then based on this data set, the data value that occur the most, or the one that has the most frequency in this case, is 2. So the mode in this case is 1, because 1 has a frequency of 2. Next we have mid-range. Okay, mid-range is we take the max, add the min, and then divide by 2. So that's the mid-range. Okay, just quickly regarding the mean, the mid-range. So those two, for example, if we use the same data set again, 1, 1, 3, 4, 5. So let's go ahead and compute the average mean here. So the mean in this case, let's go ahead and do 1 plus 1 plus 3 plus 4 plus 5. What do we have there? Divide by 5. So what is that? With 9, 10, 14. 14 divided by 5 is 2.8, right? So 2.8 is the average sample average for this one, or sample mean. And the mid-range, let's compute the mid-range as well. Okay, so that would be 1 plus 5, so min plus max, max plus min divided by 2, which is 3. So both mid-range and the sample mean is pretty close there. Now imagine we're going to throw in, another value that is quite larger than the other values from the data set. So let's say we got 1, 1, 3, 4, 5, 20, right? So 20 will be a value that is a lot bigger than the rest of the value in the data set. So if that's the case, now the mean, sample mean now, 1 plus 1 plus 3 plus 4 plus 5 plus 20 divided by 6. Let's see here. So we got 14 for the first one, so 34. 34 now divided by 6. That would be 5.7. And then the mid-range is, let's see, we got 20 plus 1 divided by 2, so that's 21 divided by 2, and then 10.5. So notice how both sample mean and mid-range change drastically when we include this extra value here. Okay, so in this case here, 20, we consider that this is an outlier. Okay, data value. Okay, we say that both the mid-range and the mean, so mean and mid-range, are highly sensitive to outliers. Okay, since the means uses every single data value, at the moment we have one large data value, it certainly is it's gonna skew the rest of the data, because that one large value it's gonna make the mean become larger as opposed to the rest of the data value. Like the rest of, like this word here, 5 of them is around like 1 to 5, but then the moment we add the 20, that's gonna just make the average, it's gonna skew the average a little bit there. Okay, so both mean and mid-range are sensitive to outliers. Now I wanna do an example where the data set is large, and certainly we don't want to compute the mean median by manually enter these data values and then add them up, divide by how many are, and also manually sort these data values and then find the median, and that's just too much work, taking away too much time. So this data set is about 50 values here, These are the magnitudes of the earthquakes. We want to find the mean, median, and then we want to discuss whether the given magnitude of the earthquake measuring 7.8 on the Richter scale uh, is an outlier or not. Okay, so that's what we're trying to do here. Okay, so how do we compute the mean? We would take all these data values and divide by how many there are. Okay, so let's see. We will have to manually enter all these data. Okay, so if I was to use the calculator, I would go to stats, edit, and then I would probably enter under one of these columns. So let's see here, clear. So I would probably enter all those data by hand. All right, so 0.88, 1.41, and search, 0.88, 1.41, and you keep doing that until you hit 51. Or we can, if you're doing this in your homework on MyMathLab, there's this button here. This is the where you will copy all the data value, open in StatCrunch. This allows us to save these data values, import or export to StatCrunch, and in StatCrunch, we can do actual stats computation that allows us to find the mean and median and mode. So let's see if I was to do that. Wait a second here. 3.1. I had the window open, but I think I close it. Okay, so this is, I believe this is example 4 of 5. Okay, so what you want to do is you want to click on StatCrunch, and then you want to do stats. Let's see, you're going to do stats, and then summary stats, and then do rows, and then one var options. All of this here means standard deviations. I think I'm gonna go ahead and save this example. This would take too long here, so I'm gonna go ahead and save this example for Zoom, and then I would do this in Zoom so that way we can record it and much easier to follow. But pretty much you want to use StatCrunch to compute the mean, median, and then discuss whether 0.7 is an outlier or not. So another thing too is here are some example of how do we know when the measure center can be used, which one is appropriate, why is it important. And I'll go over at least one example here with you here. So the first example says that the National Association of Realtors publishes data on resale prices in United States homes. Which measure of century is most appropriate for such resales? So we're asking, okay, if we look at the data, so the data is, we're going to say resale prices of U.S. homes. So imagine all the prices of the house of U.S. and that's our data set. Okay, so how do we use which measure center to describe it? If a person says, hey, what are the prices of U.S. home nowadays, and you have to tell them what would be a good value. So should we use the mean? Should we use the mode? Should we use the median? Mid-range? Right? Which one is the most appropriate, right? So let's talk about some of this. If we were to use the mean, right? So if we were to use the mean, well, there's going to be a lot of houses that are extremely, well, there's going to be a few extremely high prices that way up in the millions, which would skew the rest of the resale prices on the U.S. home quite a bit, because if we're looking at 30-40 million home prices up there, and the average price would be around 600K or 700K thousand. So that's gonna mess up the value quite a bit. So the mean won't work. So we're gonna say mean doesn't work because it's you know it's let's see, because it has the few no, let's say the mean won't work. Or actually, let's start with what will work. Well, what will be the most appropriate measure center? So I think that median is the most appropriate measure center in this case, because unlike the mean, it won't be affected by the relatively few homes with extreme high prices. And just like what we said earlier, mean is highly sensitive to outliers, so we don't want to use the mean in this case. Median is right in the middle because it's being the data set being ordered, so we just pick the value right in the center that most that describe the data set itself. So we can't use the mean in this case. We can, but it's just not accurate. Median is the most accurate. Mid-range won't be the most accurate either, right? So median is what we're going to use for the most appropriate one. I'll let you try example 2 on your own. Example 3 here, and then we can go over this in Zoom if you like. This introduced the terminology degrees of freedom, which we will see this a lot in chapter 6, 7, 8, 9. And this example kind of discuss what is the degree of freedom. And I can certainly go over this in Zoom here. I don't want to make this video already long. It's already 17 minutes long. Quickly, it's just referring to, how many values that we have control over or independently versus how many value left that we can't control once we know what the average is. So degrees freedom referring to the number of data values that are freely assigned or chosen before the remaining values that cannot be determined, given that the average of the data set is already known. So I will go over this in Zoom as well. So I'll go over this in Zoom, and I'm going to go over this example in Zoom, and I can record that for you guys. But in this lesson, all you have to worry about is how to find mean, median, mode, and mid-range. Large data set, you want to use StatCrunch there. Okay.